Good morning and welcome to day one at the Canadian Hydrogen Convention here in beautiful and sunny Edmonton, Alberta. We've got about 10,000 of our closest friends joining us from all over the world. And right now we're in the Edmonton Hydrogen Hub Pavilion and the Edmonton Global stage. We've got a full program for you over both days. So stay tuned. This first session we're doing is on hydrogen production. We've got sessions on mobility, on almost anything that you can imagine related to hydrogen, again, throughout the day, including an international student case competition and a global pitch challenge that Plug and Play is running. So again, some really, really amazing things over the next couple of days, and we're thrilled that you're here to join us. My name's Chris McLeod. I'll be one of your hosts during this convention. And again, thanks for joining us at the Edmonton Global stage. We're going to kick it off with our first session on hydrogen production technology. And joining us is Andrew Gillis, CEO of Aurora Hydrogen, and Travis Janke, VP Engineering of Modern Hydrogen. Andrew, Travis, thanks for joining us.
Yeah, morning. Great to be here. Happy to be here. Is that number right? 10,000 people in and around the conference?
Well, it's a rough number. You know, last year we had just over 8,500. Oh, wow. We thought we'd have about 8,000, but it's not until you do the count at the end that you know. This year our goal is around 10,000, and all signs look like we'll hit that and maybe pass it by a bit.
That's incredible. I was here the first year, and it was, I think more than a handful. Obviously, it was a few thousand people, yeah. But that's incredible growth.
Yeah,
over
it's
the past
funny.
2 years.
When we built this with DMG in that first year, we thought, maybe we'll get 500 people, because we didn't even say let's do this until like almost September, and then we ran it in April. And that first year we had just under 3,000. So it's really growing. It's the largest hydrogen convention in North America. Our goal is to make it the biggest one in the world, so we're off to a great start.
That's awesome. Super excited.
Yeah, absolutely. So thanks for the plug on our show. But let's talk a little bit more about you guys and what you have on the go. So maybe Travis, most people probably don't know a ton about modern hydrogen. Can you give us the elevator pitch and who you guys are and what you do?
I'd be happy to. Yeah, modern hydrogen, we decarbonize natural gas to produce clean hydrogen and a solid byproduct of carbon.
Yeah.
Which we utilize in the building material sector.
Oh, interesting.
Yeah.
So when you say building materials, you're talking concretes, pavements?
Specifically pavements. The asphalt industry, or asphalt as we say here in Canada, has taken a liking to this material. We actually have it deployed in 5 states in the US, and we've also used it up here in Alberta for some applications just to test out the material. And we have some commercial offtakes already in place. So pretty exciting that we have that in place with that carbon product, because it's a material that really needs a home for methane pyrolysis to succeed.
Wonderful. And where are you based?
I'm actually based out of Victoria on Vancouver Island. So I work remotely to support the company. My focus as VP of Engineering is obviously in the engineering space. But I have a very outward-facing role, focusing on our project deployments with our customers.
Okay. And where is Modern Hydrogen based?
Modern Hydrogen is in the Seattle area.
Okay.
So not too far. As the crow flies, only about 70 miles away from my home. There just happens to be an international border in the way.
Okay, wonderful. And Andrew?
Yeah, I'm the CEO of Aurora Hydrogen. We're developing a methane pyrolysis technology that takes natural gas and electricity to produce hydrogen at a low cost in a distributed way without any CO2 emissions. Similar to Modern Hydrogen, Travis's company, we produce a carbon co-product, but ours is a bit unique for us in that we produce a granular carbon sand that we also think has a lot of deep applications in a variety of different carbon markets. But our focus is very much on low-cost hydrogen production at the point of use.
Oh, wonderful. So what do you mean at the point of use? Are we talking industry? Are we talking mobility? Like what's the use case for that?
All the above. So our view is that we want to be moving energy using existing infrastructure, so existing natural gas and electricity infrastructure, to the point of hydrogen need, and then producing hydrogen where it's needed. So be that industrial facility to displace emitting hydrogen production. It could be industrial heating. It could be natural gas blending. It could be heavy-duty vehicle fueling, for example. So you can imagine a commercial card lock where Class 8 trucks fuel today. We believe that we could deploy the technology in those locations to provide the production and the dispensing right where hydrogen's needed.
Yeah, it's brilliant. And is modern similar to that, where it's at point of production or use, or is it broader?
Absolutely, yeah, very similar. It's the point of use,
Yeah.
leveraging the existing natural gas infrastructure across North America. We really view that as existing pathways for hydrogen. It just happens to be bound to carbon, right, in the form of natural gas. And we really look to leverage that existing infrastructure rather than look for these major significant changes to make our technology work. So again, very similar to the Aurora technology.
Well, I think we get a lot of questions about how fast is hydrogen going to be deployed. In part because it's really tricky to do hydrogen infrastructure, right? It's such a small molecule; it can escape through a normal pipe. But if you're using natural gas pipes, not all the world, but most of the world has pretty good infrastructure for natural gas, has typically excellent infrastructure for electricity. So you've really jumped over that hurdle of you don't have to build a whole nother infrastructure set. You really just have to make a facility use what's there and then deal with the carbon. So seems super smart.
I think that's the important point, and especially leveraging the distributed aspect where a lot of people, and I'm sure we're going to hear it 100 times, if not more at this conference, is the chicken or the egg. Demand, supply, supply. And the bigger the chicken, I'm going to stretch this analogy probably a bit too far, but the bigger the chicken, the bigger the egg, the bigger the problem gets. If you're trying to build a mega facility to get the hydrogen cost down, and then you need to aggregate the amount of demand necessary to justify that facility, that's an extremely high hurdle to get over.
Yeah.
Whereas if we can take new technologies that can produce hydrogen economically at a smaller scale and not need to aggregate all this demand, but be able to do this on an application by application basis, we think we can crack that current paradigm of big supply, big demand, and do it in a stepwise fashion to start growing the hydrogen market in these new applications.
Yeah, that's really interesting. Again, when you think about really big heavy industry, like the project that Dow's building, that's more than a $10 billion polyethylene facility, using hydrogen as one of the fuels. That massive build is for a massive project. But if it's a smaller community that's being built that wants to go net zero, do you want to run a hydrogen pipe all the way there, or do you want to set up a system that actually does it, and it's almost more on demand then?
And we believe that also speaks to the opportunity to have more robust energy systems.
Yeah.
The more smaller centers of production we have, we believe the more robust those systems can be. So you're not relying on centralized production. I mean, this I think speaks to the idea of in a peripheral way to energy security in the sense of reliability of systems.
Yeah.
We see with weather changes, with different geopolitical events, things like this, that large-scale energy systems, centralized energy systems, can be very sensitive to disruption.
Yeah.
So we believe that, along the same lines of electricity and other forms of energy production, it's a great way to move forward for the next stage of the energy transition.
Interesting.
I would add to that, I like to think of it as diversification as well, right? We speak to a lot of potential off-takers, potential customers that view our technology as just that, a way to diversify their energy supply. So it's really useful in that sense. I would also say that while of course there's advantages to economies of scale, the distributed approach, especially with new technology, allows you to prove out the technology in a manner that doesn't rely on major infrastructure changes. Even on a heating load perspective, you can produce hydrogen and blend that into a certain level without changing anything inside those furnaces and related equipment. So there's a real advantage for technologies like moderns, like Aurora's, to come in with very little to minimal disruption to start, but really prove out the technological approach and evolve the technical maturity to really prove that the technology has a chance.
Wow, wonderful. So how big, how small, what's the sweet spot of one of your facilities, or is it a range?
Well, for us, we believe our technology, and we intend to continue to develop in this way, is inherently scalable.
Yeah.
So our view is to have production facilities where needed at the scale required. So if that's, for example, a heavy haul fueling depot or commercial card lock that's in the 2 to 4 ton a day range, that's where we want to be. If we're an industrial facility that's requiring tens or hundreds of tons a day of hydrogen production, then we expect to be there as well as we continue our scale-up journey.
Wow.
Our approach is slightly different. We're looking more to the electrolyzer industry for that inspiration of scale. Think of it more about modularity. That doesn't necessarily mean we can't go to the large projects, but what it does mean is we're looking to cost down through standardization of manufacturing and make our products, more or less a cookie cutter piece of equipment that comes out the door that we can deploy to our customers. In certain instances, the product itself will be enough. In others, we'd likely have to work with EPC firms and take a more project-based approach. But really, that's driving our development approach today.
Yeah, it makes sense. Standardize, make that cookie. So I'll go back to the first question: is like, what's your sweet spot, or how big is the cookie? Is it a fueling station? Is it a community? What does that look like?
Yeah, for us, currently we're less focused on that end use application and more focused on creating the right size product. So our target for our first commercial unit is 500 kilograms of hydrogen a day. There's reasons for that, partly because of the carbon product. There's thresholds you hit where the amount of carbon you make is simply something that needs to be managed in a reasonable way. You go past a certain scale, and it may change the method of implementation on site. So starting with 500, we know that may change. Like any startup, your idea a year ago is different from it is today, and it'll be different a year from now. But that's our current path of development.
Okay. And are you both at production? So you've got a facility up and running, or are you still in demo stages? Like, how far on the path are you?
Modern actually recently just deployed 2 pilots to customers in the field. So we have 2 field deployed units operating. These are pilots. They generate 5 kilograms of hydrogen a day. We have 1 in Florida and 1 in Oregon. So we're well on our way to getting to a point of real world commercial validation.
You don't have one here yet?
Not here yet.
Okay, make sure we're on your list.
It's on my list.
Go ahead.
It's a target for the next couple days.
Okay, good.
So we have I'm not going to call it a production facility, but a small scale operating pilot that's, I'm going to say, about 3 blocks from here, that's doing about 1 kilogram a day. But really what we're looking forward towards is our what we believe to be as a commercially viable demo scale in Fort Saskatchewan later this year. That's about 200 kilograms a day. We expect to have that up and running later today, and then we're in fairly advanced talks for deployment of that in the first half of next year for a fueling application in the Edmonton region.
Fantastic. And 200 kilograms may not sound like a lot, but hydrogen's really light, so how much is that?
That's enough to fuel 10 buses continuously. So it's not a trivial amount of hydrogen. It's certainly, and again, we believe this is a commercially useful scale of production. So for us, this is very much a commercial, starting as a pilot, but then very much a commercial demo plant once we get it out in the field and using it for real world hydrogen applications.
Fantastic. And for both of you, the purity of the hydrogen is it a high enough level it can work in the transportation industry?
For us, out of our reactor, it's no different than industrial hydrogen production, where for those fuel cell applications, for example, you would need purification of it. But this is off-the-shelf equipment that's used every single day in conventional hydrogen production.
Okay.
Yeah, what Andrew said.
Okay. And what about like pressurization? Is that part of your mix too? Again, if we're doing transportation, you need fairly high pressure. Is that another add-on that you do as part of it, or is that part of your initial build if you're doing a transportation site?
For our technology, we consider that something that would be bolted on. And I spoke to the modularity earlier. While we would modularize the pyrolysis systems, typically speaking, we would consider that what we would call a balance of plant to be something we could scale depending on the project. And the reason for that, to Andrew's point, is those are off-the-shelf technologies. The cost and engineering that goes into that is more or less well known, relatively low risk, as long as you can hit the requirements of those systems in terms of infeed of your product.
For us, it depends on, speaking again to leveraging existing infrastructure, it depends on the infrastructure we're leveraging. So in the natural gas distribution network, it's at 15 PSI. The reactor's operating on that, it outputs it in that, so you do need to do the compression lift. It's our view that at larger scales where we're accessing transmission pressure natural gas that's say 50 bar we're operating the reactor at those pressures, and then we're just doing the lift required to whatever end use. But if we're doing for example, a natural gas blending application, it's just coming back into the natural gas line. So it depends on the end use.
Yeah, okay, makes a ton of sense. Probably the last question that people will have curiosity about in terms of your process is just, again, what do you do with the carbon at the end? So you talked about, asphalt, some concrete, or not concrete, but other construction materials. So just walk us through, does it come out as a powder? What is it? And then how easy is it to move from that site to wherever it's going to be used in construction?
Yeah, absolutely. I mean, the carbon comes out as a solid, but of course, the only thing going in is a gas. So it's a very interesting reaction where it goes from a vapor to a solid. And by virtue of that, and in our process especially, it comes out as a very fine material. There are ways to compact that material to improve on cost of transport and logistics. But of course, there's also a balance with that end-use application. How do they want to receive the material? And what then do they need to do to that material to actually apply it to their product? So we've put a lot of work and energy and effort into evaluating all of these end-use applications. You mentioned asphalt or asphalt. This seems to be an ideal application, not only because if you think about asphalt, it already uses a byproduct of the oil and gas industry as one of its core ingredients. So we're just simply adding to that matrix. There's very similar properties between our material and the existing ingredients in asphalt. So it's a great fit, and it's also a very high volume market, extremely high volume. We do have work to do to continue to develop it and prove out, its efficacy. But it's very promising in terms of, again, really leveraging an existing industry, an existing marriage between the oil and gas industry and the building materials market with this material.
Yeah, I think we'll be building and fixing roads for a long, long time. Andrew, how about you?
So we produce so we've got a unique microwave-based heating method, and we end up producing a unique carbon product. And by that I mean unique in the methane pyrolysis space, but what we've come to find is very generic in the carbon space, to our good fortune. So if you look at the global carbon markets and the variety of things you can do with them, there's sort of an inverse correlation between value and volume, right? You have very high volume, low value applications and very low volume, high value applications. And we've been doing a lot of work across the spectrum of applications. So we've had our carbon used as a common feedstock for higher value carbon production. So synthetic graphite, graphene, these kind of things, advanced materials, which is traditionally uses pet coke as a feedstock. We've been able to displace that as a preferred feedstock because ours is elementally pure, already semi-graphitized. And then you've got a big mid-market, and there are a variety, for example, of steel-making applications that use carbon products in a few different ways. And we believe that it can be very well suited for a variety of those different uses in the steel industry. And then ultimately we've got, what I should describe this a little bit, it's basically a sand-sized carbon particle. So if you think of a beach sand, it's very much a similar size distribution to that. So ultimately, we think it could be, as Travis is saying, as a displacement for mineral sand in construction aggregate applications, be that concrete, asphalt, road base, reclamation fill, earthworks, a variety of these different extremely high volume applications, and importantly, ideally applications that are local to the hydrogen production.
Yeah, love that. And it's interesting too, because it's taking something that most people are thinking of as a waste product and turning it into a value added. And some of that is a lower quality value add, but if you're doing carbon nanotubes and you're doing graphene, like those are really valuable. We're actually also working on some projects around trying to build silicone chips and other things that are that type of material can be really valuable in a whole broad variety of technical applications.
As can the hydrogen in some semiconductor manufacturing applications.
Oh, I didn't realize that. Go ahead.
I just wanted to add to a comment Andrew made about the local application. I think that's an important point to touch on. Obviously, our technologies generate hydrogen, and we're looking, at least at Modern, and similarly at Aurora, to decarbonize natural gas. Well, if we're going to decarbonize the natural gas, that carbon has to go somewhere where it's sequestered, and it can't travel significant distances. This is another reason why the asphalt industry is so attractive is because, to your point, there's roads everywhere,
Yeah.
and it's a very distributed production network. So there's a strong link between the distributed approach to methane pyrolysis and co-generating hydrogen and carbon, and that distributed asphalt industry.
Super interesting. I have to be a little bit careful not to just jump down rabbit holes, because everything you guys are talking about, we could just spend like a half an hour talking about each one of these. But your comment about like the semiconductors and hydrogen, I haven't heard that before. So can you tell me just a little bit more about what you're talking about?
Yeah, I mean, I'm not an expert in semiconductor manufacturing, but my understanding is in a lot of...
Too late now, you're on mic talking about it.
Really. In a lot of clean room applications and high-value electronics, it's used as an oxygen scavenger in those processes where you don't want oxygen in the manufacturing process. Yeah. So most semiconductor manufacturing facilities have hydrogen tanks out back that are using hydrogen for the manufacturing process.
Yeah. Very interesting. And again, not to stay too long on that subject, but we've got a project we're working on in our region around semiconductor manufacturing and trying to put all the pieces together for why it's the right thing to build here. Not just because we have dozens of companies in this space, but now we can add hydrogen. And I hadn't actually thought of that. That's another advantage.
It's a spot of endearment for my co-founder, Dr. Aaron Bobicki, who in a previous career path worked for Intel in semiconductor manufacturing.
Oh, wow.
So if you want to have a lengthy discussion about that, I'll point her in your direction.
We'll need to get hooked up. Okay, so we've got about 8 minutes left. Again, we've got people all over the world that are watching this. We've got many investors here, for this convention as well. Can you talk a bit about what your path to, the money you need to build the company to whatever scale you're trying to get to? Are you still looking for investors? Are you what series are you at? Give us a bit of a sense of the financials of where you're going.
Yeah, happy to. I mean, as I said earlier, we have pilots deployed in the real world, so we see that as a huge milestone that we've hit. Within the next year, we intend to deploy our first commercial product, which again would be a commercial pilot, but nonetheless, this would be at a 500 kilogram per day scale of hydrogen. We're in good shape to hit that milestone. Beyond that, we'll be looking to enter that next phase, which we see as being really a growth in our ability to manufacture our units. And to my earlier comment on the standardization and modularity of these systems, that's where we'd like to make that investment, is taking this technology down the cost down curve and entering that next phase of investment, which will be significant, but required to invest in that infrastructure internally within the organization to be able to produce a unit for a few $1 million rather than the cost that, of course, the first few units will be, which is normal and natural.
Yeah, interesting. And so in the Edmonton region, we build big things. We have the second largest metal fabrication basically space in North America. There's a little bit more around Houston, but we're number 2. Mega projects get built here all the time. And there are quite a few companies that do build modulars for others. So if you're looking for space to build that first facility, we can also talk about that as we're talking about silicone on another one.
Let's do it. I'd love to.
How about you, Andrew? Where are you guys at?
So in 2022, we took our first outside capital. That was our first venture round. It was led by a US VC firm called Energy Innovation Capital, and we had co-investment from Shell, Chevron, and Williams. And that was to provide funding to get our pilot, this pilot/commercial demo up and going. Once we're successful in that later this year, it's our intention to go out for another funding round early next year to support the growth. Growth in the product, so scaling up the technology, hitting our next increment of significant scale, as well as starting commercial deployment. So that's something, if there are investors out there, please get in contact. Early next year, we'll be looking to collect more funds to support that growth.
Okay, perfect. And are you at the stage where you're looking at market entry and where you're going to kind of build from and move into, or is it still more about just getting the production technology figured out?
Absolutely, we're taking market feedback and trying to inform our scale-up path. And as you asked about, compression, purity, like these are factors we need to have in the front of our mind when it comes to making sure our technology is well suited for the applications that are out there. So we're actively getting market feedback, building a pipeline for early stage commercialization. So if anyone has an interest in getting in contact with us for commercial reasons, we're actively having those conversations right now.
Okay, fantastic.
Yeah, thanks. That's very similar to our approach. I will say, just to add to, the various applications, there's a lot of interest out there. There's a lot of different applications. We have to consider all of them, but also be very smart about which one is our first step, which one's our second step. And even more importantly is find those strategic partners that just get it. They understand what it takes to be a pioneer in this space. So we spend a lot of time, obviously, listening to all opportunities that are out there in the market, but we work very diligently at evaluating each scenario on a case-by-case basis and looking for that sweet spot, both for projects today and then projects 5 years down the road.
Yeah, it's got to be the right fit. It's got to make sense for your long-term goals. Are there countries though that you're more interested in? Like, are you starting Canada to U.S., then going, or are you looking at Europe or Asia?
On our end, we're a U.S. company.
Yeah.
We're swimming in natural gas down there.
Yeah.
There's 3 million miles of natural gas pipeline existing infrastructure across the U.S. That's our primary focus, at least for the first handful of units. Of course, Alberta is a great opportunity as well, for the same reasons, swimming in natural gas. And when you compare some of the competing emerging technologies like electrolysis, Alberta obviously has that challenge of having a electrical grid primarily driven by natural gas. Right?
Yeah.
So Alberta is absolutely on our radar, but chances are first 1, 2, 3 to 5 they'll be down in the U.S.
Well, I guess you can decide to do that. We think Alberta's the better play, but more power to you.
Open to discussion.
And Andrew, how about you?
Yeah, we've got an initial focus on North America, but certainly we're doing as much as we can in our backyard here. We're an Edmonton-based company. We're doing our demo in Fort Saskatchewan. So this is certainly where we want to do business. It's the easiest and most pleasant place for us to do business. And then taking a step away from that, North America is our next priority. And then we do understand there's strong opportunity in some international markets that we intend to pursue once we have a strong foothold in our backyard.
Yeah, exactly. Stable growth, don't go too fast, makes a ton of sense. And by starting here, you get to take advantage of all the infrastructure that's here, the education, the broad networks. And again, I think we are one of the places in the world that's moving, if not the most aggressive, certainly up there in terms of really trying to deploy hydrogen at scale. Yeah,
and in the hydrogen space, Edmonton is one of the world's largest hydrogen production and consumption centers. So the expertise is absolutely here, the ecosystem is here. We were a COVID startup, notionally we could have planted the company anywhere, but it was abundantly clear that Edmonton was the right place to do it.
I didn't realize it was that recent. Aurora Hydrogen's got a pretty big footprint, both here and I'd say all across the country. I spoke at an event at the Toronto Global Forum about a year ago that you were one of the key speakers at. So you certainly have very high profile, but it's only a couple of years old. That I actually kind of find that shocking. Yeah, no, that's right. I think we incorporated and filed our core patent applications in 2021. Yeah, so it's been a wild ride. Yeah. Wow. Yeah, good for you. Okay, we're into the last minute. Maybe just a comment from each of you on what are you looking forward to at the show? Are the things or people you actually want to absolutely make sure you meet? And it's a plug for people to show up next year. So just, what are you looking forward to and what are your big goals for this show? Yeah, from my perspective, these conferences and the Edmonton Hydrogen Hub that's being built here is so impactful to the hydrogen economy. Being here, absorbing from everyone that's involved, learning about some of those mega scale projects, understanding where the real interest falls in terms of end use application, and what the barriers are to growth. That's really what I'd like to learn from my time here, and of course just to get to know new people and make some new friends and
have some contacts to stay in touch with, because Alberta is on our radar.
Fantastic. And we are a friendly place.
On a personal level, doing a startup's hard, hard tech's hard. We spend most of the year with our head down, just grinding away on making sure we're making progress and hitting our milestones. So for me, the Hydrogen Convention is a great opportunity to lift our head up a little bit, get reinvigorated, look at all the things that other people are doing, and really reset for the year. Think about long-term purpose, thinking about the future of hydrogen in the region and around North America. So it's great to lift our spirits and get going again for another year.
Yeah. Well, again, thanks so much, guys. You're both with companies that are real leaders in this field. Decarbonizing our energy systems is one of the most important challenges that we have as a planet. So to meet with the two of you who are really, again, leaders in this space, leading companies in this space, it's really humbling to have the conversation with you, and just so love what you're up to. So thanks again so much for being here.
Yeah, thanks, Chris. I really appreciate it.
Thank you.
Okay, so this is the end of the first conversation here at the Canadian Hydrogen Convention. We've got all day today, all day tomorrow. And if you enjoyed this conversation, and how could you not, conversations just like this will be on the Future Simple podcast. That's a new podcast by Edmonton Global that launches right after the Hydrogen Convention. We'll be talking to people from all different walks of life in hydrogen and energy, in artificial intelligence, life sciences, people who are absolute experts in their field to take these really complex challenges and make them simple just for you. Okay, so again, this is the end of the first little panel. We're going to take about a 15-minute break, and when we come back to you, we're going to have a trailer of a project that we're working on that is it's a mini kind of documentary series, and we started filming that at COP in Dubai last fall with our partners, Bad Films. And so when you come back, that's what you're going to be seeing first. Okay, so thanks again, and we'll see you soon.